Hello, how y'all doing today? My name is Bernie Thompson. Today we're here to take a look at this 2005 Jeep Rubicon. This Jeep Rubicon has been deemed unfixable. This has a transmission problem. It's been to 2 tranny shops and a dealership. So far, they've taken the tranny out 4 times, totally gone through it. Different tranny men have done this. And the tranny man that brought it here, I know this guy, and he's a top-notch tranny man. I've done work for him. He's really good. And so the tranny, he's sure it doesn't have a problem. So then they put on 3 PCMs, 3 powertrain control modules, and they've put on 3 or 4 solenoid packs. The last solenoid pack was put on by the dealership because it was an aftermarket one and they thought it needed to be a Chrysler product, so they put on a Chrysler one. So every single part that could have to do with this tranny has been replaced. The code we're looking for is a P1776. Then that's an LR switch. It says the LR switch is coming off at the wrong time. So what we need to do, the first thing I want to do is get a scan tool on this car and get the codes, and then we're going to get a scope connected and we're going to go drive this car. Let's go ahead and get this scan tool in. Okay guys, I pulled the codes on the car, off the car, and I've got a P1776, and that's the LR switch is on. So this is the tranny code they've been trying to fix. Is an unfixable car. So I know right now, guys, I don't want to use the scan tool to find this problem. I've done a lot of tranny jobs and I need a scope to find this. So the first thing I'm going to do is I'm going to get a scope and then we're going to go test drive the car. So let me get my scope connected. Okay guys, I found the PCM and I found the wires for the TCM for the circuits that we need to begin to test this problem. Channel 1 yellow is in the LR solenoid. Channel 2 red is in the LR switch. Channel 3 green is in the 2-4 solenoid. Channel 4 blue is in the 2-4 switch. Channel 5 white is in the overdrive solenoid. Channel 6 purple is in the overdrive switch. Channel 7 is in orange is in the underdrive solenoid. And channel 8 brown is on an amp clamp, and we're reading the current going to the LR solenoid. So now let's get the scope and check it to make sure we're in these wires correctly. Okay guys, we've got the leads connected to the TCM. Let's make sure all the leads are connected correctly. All the red lights are out, and if the red lights are out, if the circuit wasn't connected, we'd have these channel lights on indicating we had a bad connection. But we don't have that, so we're connected. So now I want to come over here and I want to record. And the first thing I want to always do when I'm working on these is I want to turn the key on and look at the self-test. Right there, guys, that's the self-test. You see how let me expand this. See how it pulls to each of the solenoids in order? This is the car's self-test, and before it's going to allow the tranny to work, they turn on all of these. So there's 2 places we need to look at here. One of them is at the top of the flyback voltage. The flyback voltage is caused by the current that's going through the inductor. So if I have a current problem, I'll see it up here in the flyback voltage. The other thing I want to do is I want to look down here. So right here, this is the bottom of the waveform. And at the bottom of the waveform, you can see this curve. This is the amp ramp, and this will match an amp clamp identically. So this is really a good way to check these. All of these are even, so we're good. And then all of the tops are good. So if we look at these tops, they're real close, so the current's all about the same. And then if we look at the bottoms, they're all about the same. Now, okay, guys, what's going to happen is if one of these is wrong, what's it going to do is it's going to continue to pulse these. It'll pulse. So if it finds that the current's not right in one of these, whether it's shorted or it's got resistance, the current will be wrong. And it looks at the bottoms and also looks at the top of the flyback. So what's going to happen is then it'll set a code for this. But this is a way I can do the test before I go on a test drive, just to make sure all the solenoids look good before we go out and get them hot. So I always check them like this, and it works out just great for me. Now, do you see how we only pulse these one time? If it sees one of these fail, you'll see it have 4 strikes, and then right away it's going to do another self-test, 4 strikes, and then it will do a third self-test, and it'll be a strike. So there's 3 strikes. It tests 3 times. If it fails the first one, it tries 2 more, making sure that it's bad before it goes into default. If one of these is bad, the tranny won't come up. It will be defaulted. They won't allow it to work, because if a solenoid won't work, then you could damage the tranny. So first test that they're always going to do is run the solenoids. And a self-test where the key comes on isn't just for tranny, guys. This is all kinds of things on a car. You need a scope on it, and you need to turn the key on and see if they're going to run some kind of a self-test. Very, very important. So right now, all the solenoids are working correctly. I don't see any problem with that. So we need to go drive this car and see why it's defaulting. So let's go ahead and go for a test drive. Okay, we're on our test drive, and you can see, okay, we're in first gear. You can see the LR is in yellow and the 2.4 is in green. We're in second, nothing's being applied. That's default, but we have not default at this time. That we're actually in second. There's third gear. So we're in third gear right there. There's the TCC, and we're in fourth gear. So we're in fourth gear, and we got the TC application on. You can see the LR solenoid in yellow is being applied. That's being used as the torque converter clutch application. In orange, that's the overdrive and underdrive solenoids getting me fourth gear. Okay, we're still in fourth gear. We're still in fourth gear. There we're in third gear. So we just took a downshift from fourth to third. There's our TCC application right there. So we're in fourth gear with the TCC on. And we can see that the LR switch in red is still high. It's not failing. We've been driving this car for quite some time now, and we still haven't gotten it to fail. So my battery is getting low on my camera now. So I want to change something on the scope. I don't know my camera is going to continue to work, so what I want to do is I want to come over here. So I want to set the time up a little differently, and then I want to go into a deep record. Okay, so I want to change something right now. I want a different overlay in this pattern. So I'm going to switch the yellow and red leads. So the red will now become the solenoid and the yellow will be the switch. That'll make it easier for us to see when it fails. Okay, now the red is the LR solenoid and the yellow is going to be the switch. You see how the yellow is pulled down to ground? That's because we have pressure in that channel. We're applying the LR clutch pack. Now do you see how the yellow popped up right there? That shows us that the switch got pressure off of it. Okay, we're in third, we're in second. Do you see how the yellow over-traced the red? So this is how you can change your color overlaying so you can see something. So right there, that's what should happen. So let's stop that for real quick. Okay, what I want to do is right here. You can see where the color overlaying did? Now this is where we're getting first gear. It's commanding it. No, I'm going to turn the green off. Okay, now, right here is where we're turning on. The LR solenoid is turning on, and as soon as the LR turns on, we pull down the switch. Do you see how we pulled down here? Let me turn this off. Now this is when it's applying first gear. This is the waveform we're going to see when we're applying first gear. The solenoid turns on, and then there's a delay, and I have my switch pulled down. This is trying to apply first. We'll start this over again. Let's go. So you can see the yellow trace is totally grounded because that channel has pressure. Now it unlocked the LR clutch, and you can see the pressure come up in yellow when the pressure was relieved off of it. Now we're in third gear. So we can see we're applying the TCC in third gear, and the yellow trace is high. It is not being pulled down. We've been driving this car for quite some time now, and we still haven't seen the failure. Now, from what the code says, the yellow trace is going to pull down when we have our problem. But my camera is running low on the battery right now, and I've already changed the batteries. So I don't have another backup battery. I just hope we get this before my camera drops off. You know, they said it was intermittent. They didn't say it was going to take hours for this to occur. Okay guys, we're right off of the test drive, and we finally got this Jeep to fail. Almost 2 hours of driving this vehicle. Now when they said it was intermittent, no one said you had to drive it for hours to get it to do it. But you have to drive this vehicle for hours in order to get this vehicle to start to fail. But all you need is one failure. I got one capture, guys. This is the failure right here. So let me go through this data with you so you can understand how to diagnose these trannies. This is referred to as data-driven diagnosis, and I'm going to show you what I mean by data-driven diagnostics. So let's go ahead and look at this way. Okay guys, here's my save. Let me show you what's going on. The red is the low reverse solenoid, and the yellow is the low reverse pressure switch. The green, that's the 2-4 solenoid. The white is the underdrive solenoid. So if underdrive is on and 2-4 is on, I'm in direct gear or third gear. Now the first thing somebody needs to ask is, if I'm in direct gear, why am I trying to obtain low reverse? Okay guys, Chrysler does something, and this is on pretty much Chrysler, Jeep, Dodge products. They use the low reverse solenoid, and it becomes a torque converter clutch application. So I'm in third gear here, and what I'm trying to obtain is TCC. Okay, this is the TCC being applied. Let me show you what's going on so you can better understand the data. We need to do data-driven diagnostics on this car. We're not going to fix it. We're not going to diagnose it. We don't fix anything. I just diagnose stuff. I don't fix anything. I just diagnose it so the shop can. And I'm not a tranny man. I'm just a diagnostician. Okay, so the red is the solenoid. I pulled the red, the LR solenoid came on, and I immediately pulled the LR switch. Now to pull the switch to ground, it takes about 18 to 20 pounds of pressure. So if I continue to let this cycle, I would eventually build enough pressure, and I would apply the LR clutch pack in third gear, and I'm going to damage something. That would not be good for this tranny, so that would be a bad thing. So what's going on is every time I turn on the solenoid, I pull the switch down. Here I turned on the LR solenoid and I pulled the LR switch. Solenoid, and immediately I pull the switch. This is the key to know what's wrong, guys. Right here is telling me what's wrong with the car. Okay? We can also look right down here. Do you see the current ramp? You see the gold wing? Well, that's an indication that the valve actually moved in the solenoid. But what I want to do is I want to show you down here. Do you see how this right here, do you see how we've got these little divots down? Well, that's the gold wing. That's the current changing in the ramp. This is the solenoid valve moving. That's the solenoid valve moving. It changes the resistance and the current, and you can see the valve move because it induces voltage in the inductor, and then it drops the current. So that tells me that the valve is opening and closing. And we know the valve is opening because we're building pressure, right? Because this is what's setting the code. Let's be clear here. Every time that the solenoid opens and we pull the switch down, the computer is seeing that. Now, this is obvious that the computer did the right thing by defaulting the tranny. If it didn't default it, it would lock that clutch up and we would have a damaged transmission. So the TCM is working perfectly. Whoever put 3 TCMs in this vehicle has no idea how to diagnose anything. I mean, really? Come on, guys. It better turn it off or we get a problem. So all the TCMs are perfect. There is no reason to replace those. That's just a lack of understanding on whoever was working on this car. So here we go. We can see every time we turn on the solenoid, we pull the switch down, and we're building 18 pounds of pressure at least to turn that solenoid on. These are the keys that I need to understand in order to diagnose this car. So now I need to do one other thing. This is what's wrong, is we're turning on the low reverse solenoid and we're pulling down the low reverse switch immediately. That's not going to work, guys. So now is what I need to do is I need a hydraulic diagram. Okay, so here's my hydraulic diagram. Now it's going to be really hard to show this on the film here, so I'm going to go print these, and I need a second to look at them so I can figure out how the fluid flow is flowing, so I can figure out where my problem is. So let me go print those, and then we'll take a look at those and I'll explain exactly how you do this data-driven diagnosis on these trannies. Okay guys, I've printed out the hydraulic diagrams for this tranny and I've had enough time to go through them and I can see where the problem is. So let me show you how you would do this. You'd go first, we're going to start with first gear. And we can see that this is the pump, so we bring the fluid into the pump and we pressurize it. We put it down this channel as mainline pressure. It comes up and it goes across the valley of the manual valve. This is the manual valve. Comes across the valley, comes up this passage, comes up to the LR solenoid. So now when we pulse, we put current through the LR solenoid, we open it and the fluid goes through, and then it's going to go through this valley of the solenoid switch valve, and it's going to come across the valley up this passage, and it's going to apply the LR clutch pack. And in this passage, notice we got this switch. So this is the LR switch. This is what we see in yellow, and the LR solenoid is what we see in red. So this solenoid is in red and this is in yellow. So what we can see is we see this solenoid turn on, allowing fluid to go through, and then it puts pressure in this passage and this turns on. Now this doesn't turn on until about 20 pounds of pressure. That's why you have a little latency between when you see the solenoid turn on and when this is pulled to ground, because it takes a little bit of time to build the pressure up in this passage to build 20 pounds up to where we can pull that switch to ground. So this valve, when it's in this position and we pulse this solenoid, we see this switch get hit. The other thing I want to show you is in first gear, we have this pressure come up here, we come across and we go to the 2.4 solenoid. Now when we saw on the scope, we were pulsing the LR solenoid, and when current flows through this solenoid, this is normally vented, so when we have current go, it opens it and allows fluid to go through it. When we apply current to the 2.4, This is normally applied solenoid, so this, when we apply current through this, we close this. That's why you don't see any fluid coming out here. This is closed, so we're pulsing these two to get first gear. But we also have another solenoid involved for first, and we have the pressure come across the manual valve, comes up this channel right here, comes across, and comes to the underdrive solenoid. Now this is also a normally applied solenoid. So no current means that the fluid flow can go through this solenoid, and it comes up to apply the underdrive clutch pack. So in first gear, we have the LR clutch pack applied and the underdrive clutch pack applied. Now let's go ahead and take a look at second gear. So in second gear, all of the solenoids have no current going through them. This is default. So if I shut all the power off to the solenoids and I no longer power them, default to second gear. So none of these are under control. So you can see the pressure comes up out of the pump, comes up this channel, comes right up here, goes to the 2-4 solenoid. This 2-4 solenoid is normally applied, so the fluid goes through it, comes down across the manual valve, comes up here, and comes to the 2-4 clutch pack. Now I want you to notice that I have a channel off of this right here that's going to come down into this valve, this solenoid switch valve, and it's going to put fluid and build pressure up in this passage right here. I also have the underdrive solenoid, and this is open, so pressure is going to come up and go to lock up the, or to apply the underdrive clutch, and right here we've got a passage right here, and this passage is going to come across here, it's going to come up, and this valve has a valley, and the pressure comes up through this valley, and it comes down this passage right here, and it puts pressure on this nose right here. And when I put pressure on this nose right here, it moves that valve back. Notice when the valve, what we're dealing with is we have pressure pounds per square inch is really force per area. And the force per area comes on this side, and notice that this has a bigger diameter than this. So if I have the same pressure on both sides, mainline pressure on both sides, I would have more force because I have more area here. So it would force the valve to the toe. And when it forces the valve to the toe, I want you to notice something. The LR passage is now blocked. The valve comes right over this and it blocks this. So if I pulse this valve, the fluid could never get into this channel to hit that switch. And even if the fluid bled across this valve, it could never build pressure in this channel, because notice this green area is the vent sump. So any fluid that could get into this area is just going to drop down and get into the sump. So I could never, if I turn this on, I could never hit the switch. So we know that the valve is not in this position right here. We know that for sure when we're having our problem. So that's default. Now let's look at third gear where this tranny failed. Okay, so in third gear, we have the pressure come down here, come up through the manual valve, and it's going to come up right through here, and it's going to come across the underdrive solenoid right here. And this is naturally applied, so fluid will come through this and it will come up to apply the underdrive clutch pack. The other one is the fluid will come across this valley and come up here, and it'll come to the overdrive solenoid. Now we're pulsing the overdrive solenoid on the scope, right? That's opening this, because this is normally vented. So this is opening this so fluid can flow through this. So this one is naturally applied, so we don't have to control it, and we're going to have fluid come up to the underdrive clutch. This one we're controlling so we can have fluid come up to the overdrive clutch. And notice we are pulsing the 2-4 solenoid on the scope, and we're pulsing the overdrive solenoid on the scope. Now when we pulse the 2-4, this is usually normally applied, so when we have current going through it, we closed it. Notice how there's no fluid coming out of here. When we're pulsing the 2-4, we've closed the solenoid so no fluid can go through it now. This is normally applied. So the 2-4 and the underdrive solenoids are normally applied. They're open. If we pulse them, we're closing them. Okay, so now in this position, we have fluid coming up through to the underdrive clutch, and we have this passage right here, and we can see this passage come up, and in the solenoid switch valve, we have pressure that can come up through this valley and come down and come up to the nose. And now this pressure is under the nose, and we force this valve back. Now notice that we have pressure on this nose, and this is a bigger diameter, so even if we have the same pressure on this side and this side, if they're both line pressure, we have more force because we have more area on the side of the valve, and it's going to force the valve to the toe. Now notice what happened. This unblocks, and now I have this passage from the LR solenoid open into this blue area, and this blue is the control for the torque converter clutch. So now when the LR solenoid, now when we pulse the LR solenoid, we have fluid controlling, and we're controlling the torque converter clutch position. That's why this is called the solenoid switch valve. It's switching between applying it to low reverse and the torque converter clutch. So that's what this valve is one of the valves that's in play in applying the torque converter. So this is the valve that's using this solenoid for two different positions. It's using it for low reverse, and it's using it for the torque converter clutch. Okay, now if we pulse this valve right here, and this is in this position where it should be, if it's in this position right here, this is what we have to control the torque converter clutch. We have to have this valley of this valve open for this passage right here, which means the pressure has to be on the nose, pushing this valve back against the heel. And it moves the valve back against the heel, and now this passage is open where I can control the torque converter clutch. Okay, so we know that this valve cannot be in this position right now, because if we turn this on, we couldn't put pressure in and hit the switch. Notice that this whole system is into a vent, a sump vent. So even if we had pressure bleed across the valve, it wouldn't build pressure up here to where we could see that switch come on. It would just dump into the vent. So this valve cannot be in this position. So the valve, the only way that we can have our problem, this valley of the solenoid switch valve, this valley is open to where it channels this pressure up to apply the LR clutch. Comes up right here, comes to the LR clutch. That way when we hit this, we hit the switch. We hit this, we hit the switch. Now what's supposed to be happening is when we hit this, the pressure goes in to control the torque converter clutch, not apply this switch. So we know the valve is in the wrong position by the data that we have. So now I have to ask myself a question. How can that happen? And the only way that I can see that happening is if I lost this pressure over here on the nose. And if the heel has more pressure and this has less pressure, then the heel, even though this area is smaller, I'll have more force, and I'll force that valve back against like this. And then I'll line this channel up, so when we start to TCC, I pulse this and I hit this switch. And the computer is seeing the switch get pulled down, so it knows that I'm going to build too much pressure, and I'll eventually apply this LR clutch. And if I apply the LR clutch when I'm in direct, well, that's a bad day for this tranny. It's a double rut row day, because that'll burn this tranny up. You can't have the LR clutch lock up when I'm in direct or third gear. So they're going to default it, and the default is correct. The tranny control sees that we would be building too much pressure, and we would eventually build up this LR if I've got this channel aligned. If this valve is pushed back against the nose, this passage, this valley will align with this, and it'll carry the fluid up to the LR clutch. And it has, the engineers understand this, so they safeguard it to where when they see the switch getting pulled down, they default the tranny to protect it so it can't burn up. Okay, so the only way I can see this, if this pressure over on the nose, if this pressure right here leaks off. Now normally what I've seen this problem several times in the past, And normally, because this valve is stroking in this bore, it wears the bore out over a lot of miles. But we know that that can't be what's wrong with this one, because we've had 2 tranny men go clear through these valves, and they both are saying that this valve in the bore is fine. So now I got to figure out how I could lose pressure here. And guys, I'm not a tranny man, I'm a diagnostician. So I called the smartest tranny man on the planet, Wayne Colonna. And Wayne sent me this, and it's what he says, is he says that bore can be good and this valve can be good, and the retaining plug at the end has to seal. When they bored that valve body, when they machined it, they have to have a way to seal it so it seals the pressure in. And they do that with this little retainer right here. And that retainer has to fit that housing tight. And if it doesn't, the pressure will bleed off. And if the pressure bleeds off around that cap, I lose the pressure. I lose the pressure on this end because it's bleeding around the cap. And then that will put this valve in the wrong position. It'll put it in align this valley with this passage here, and we'll start to apply the low reverse. So we know that this valve is in the wrong position. That's what the data tells us from the scope. Okay, so now, and thank you, Wayne, so much for straightening me out on this tranny, because I wasn't sure what to tell him, what's wrong with it. But Wayne is pretty sure that this retainer is what's leaking. He says he's seen it to where the valve and the bore are fine and the fluid is leaking past that retainer. And he sent me this with an email. Thanks again, Wayne. I sure appreciate the help. So now we know what to do to fix this car. So this is data-driven diagnostics. Okay guys, wasn't that just a cool diagnosis on this little Jeep Rubicon? I always really like diagnosing these electronic transmissions. It's always fun. Now the way I've done this, I've laid out for you, took me years to figure out how you use a scope and apply it to a hydraulic diagram. But I've been doing this for many years now, and I know that this really, really works well. So what I want you guys to do, if you're good with electronics and you do performance, like engine stuff, don't be afraid to go around to the tranny shops in your area and tell them that you can help them with their electronic transmissions. You'll get work and it'll be great work. Once I sold my shop, I was fully mobile, and then I just went from shop to shop to shop, and I probably had 10 or 11 tranny shops that I serviced regularly. And what I would do is I'd go to the shop, I would do a diagnosis like this, and my job is to divide the tranny. Is it in the electronics or it is inside the tranny? If it's inside the tranny, guys, I'm not the tranny man, I'm a diagnostician. So then I leave, and the tranny man, I tell him what I think is wrong, and he pulls down the tranny to fix it. If it's in the electronics, I fix it, and then I get paid more for fixing the electronic problem. So don't be afraid to take on this work. You can do this work. The one thing that I can sort of warn you about is 2 and 4 tray scopes just really aren't enough to do this kind of work. You have so many solenoids, and a lot of these cars have timing solenoids. They not only have the application solenoid to apply the clutch pack, you have timing solenoids, and you have switches. And sometimes 8 traces isn't enough, but 8 will get you in the ballpark where you can see what's failing. The other thing I got to warn you about is some of the caravans that I've done. I've had several caravans that I did that will give you the wrong DTC switch. It says, like this one said, it's the LR switch. It would claim it would be that, but one of the other switches fail. And when I had my scope on all the switches and solenoids, I could see which switch was failing. And the failure was coming from a switch that wasn't even coded. Well, really, that's a hard car. But I remember those cars because, man, you start believing these DTCs, guys, and you're going to have a bad day. You really will. Don't believe DTCs. It's just a piece of data along the way. It's just one more piece of data that I get so I can use it in my diagnostics. But don't always believe them, because sometimes they'll leave you astray. Believe the scope data. That's real. That's being recorded right now in the electronic system. If you believe the scope data, you too will have good troubleshooting in your base.